Hey you guys, I just wanted to upload a video real quick about what we went over on chemical equations and how do you balance chemical equations. So the first thing that I want to go over with you guys today in this review video is the parts of a chemical equation. So let's write down one of our equations that we used in class to practice with. Okay, so remember that in a chemical equation, everything on this side of the arrow is called a reactant, and everything on this side of the arrow is called a product. And we can read equations like we do sentences. For example, this equation reads nitrogen plus hydrogen yields ammonia. And so this allows us to see what happens when we take two chemical molecules and combine them, two or more I should say, and combine them to make a new thing. And that's what a chemical equation shows us. In chemical equations, we have to be able to balance them because in class, remember, we talked about the law of conservation, and that says that matter cannot be created or destroyed. So we always need to have the same amount of atoms on this side of the equation as we have on this side. So our reactants should always equal our products. As we can see with this equation, as written, that's not the case. Here we have two nitrogens on our reactant side, but we only have one on our product side. This means that somewhere we lost an atom of nitrogen, which is not possible. So we have to balance the equation to show that none of our atoms were lost. So how do we do that? Well, we use coefficients. And coefficients are those big numbers that you see in front of the chemical compounds that are in a chemical equation. To be able to balance this equation, the first thing we're going to do is we're going to take an inventory of what kinds of elements are in this equation. So, for example, we have nitrogen in this equation, and we have hydrogen in this equation. Now that we know what elements we have, we need to start counting how many we have on each side. So on this side of the equation, on the reactant side, we have two nitrogens. This subscript of 2 here tells us that there's 2 of these. And then on this side, we only have 1 nitrogen. So we've got 1 over there. We have 2 hydrogens on our reactant side, and we have 3 on our product side. Remember, this subscript tells us that there are 3 of this atom. So we need to balance this. We're going to use coefficients, which if you remember are those big numbers that go in front of the chemical compounds to balance this equation. So I have 2 on this side and 1 on this side. I need to find a number that I can multiply by 1 to equal 2. Well, that's clearly 2. So if I put a coefficient of 2 right there, we change this to 2 nitrogen. So this coefficient applies to this N. It also applies to this H, which changes how many hydrogens we have on this side of the equation. So now we have 2 NH3 molecules, which gives us a total of 6 hydrogens. So the coefficients, they distribute to every atom within the compound. So remember, this is a chemical formula for a compound, NH3, and we have 2 of these, so that means there are 2 nitrogens and 6 hydrogens. So now we need to balance our hydrogens. I need to find a coefficient that I can multiply by 2 to equal 6. That would be 3. So I put a 3 in front of my hydrogen, and now that gives me 6 atoms of hydrogen. So law of conservation, check, check. We have 2 nitrogens on both sides. We have 6 hydrogens on both sides. We did not create or destroy any matter. Okay, so this is a pretty simple example of balancing a chemical equation. Let's try a harder one. A harder one. Okay. Let's try one where we have some of those good old parentheses polyatomic ions that drive you guys crazy. We went over this one in class, so it's a really good example of one that has a polyatomic. So let's try it. We have aluminum bromide plus potassium sulfate yields potassium bromide and aluminum sulfate. There we go. So step 1. What elements are involved in this equation? Well, we have aluminum, we have bromine, we have potassium, and then we have sulfate ion, or sulfur and oxygen. We can do this one of 2 ways. You can keep this together as one, or you can separate it. like this. It depends on how you want to do yours, okay? I'm going to do it both ways so that you guys can see that it works out the same way no matter how you do it. Let's try it this way first. So now I'm going to inventory how many of each atom I have on either side of my equation. I have 1 aluminum here, 2 there, 3 bromines on this side, 1 on this side, 2 potassiums on this side, 1 on this side, 1 sulfur on this side, 3 on this side, 4 oxygens on this side, and then 4 times 3, that would be 12 oxygens on that side, okay? So let's start balancing. I need a coefficient to balance these equations with. So if I want to have 2 aluminums on this side of the equation, that means I'm going to put a 2 in front of the aluminum containing compound, and that makes that have 2. That also changed my number of bromines from 3 to 6, so I need to change that. To balance that on this side of the equation, I'm going to put a 6 here as my coefficient, which is going to change this to 6, but it also changes my potassium to 6, okay? Then I need to balance my potassiums. To balance potassium, I have 2 on this side, 6 on this. 2 times 3 is going to equal 6, so I'll put a 3 right here, and that gives me 6 of these. That also changed how many sulfurs I have, so it changes that to 3 sulfurs, and then 3 times 4 oxygens, which is 12, which means that this aluminum is balanced, bromine is balanced, potassium, sulfur, and oxygen. So that's one way that you could have tackled this one. If we were to go in and try it the other way that I showed you in class, I'll rewrite my list. Bromine, potassium, and then leave sulfate as a polyatomic ion. Why? Because it's in parentheses right here, and it's right here, and it doesn't change, so we can leave it as 1 unit. And let's count. 1, 2, we've got 3 bromines on this side, 1 on this side, 2 potassiums here, 1 potassium here, 1 sulfate ion, 3 sulfate ions. Now we balance. So I want to put a 2 here so that I can have 2 aluminums on that side. That also changes my bromines to 6, just like we had before. So I'm going to put a 6 here to balance that. That changes my potassium to 6 as well, so I'm going to have to put a 3 here to balance out those potassiums. Changes that to 6. It also changes my sulfate ions from 1 to 3. So we've got balanced, check, check, and check. We've obeyed the law of conservation, and we have a balanced chemical equation. Okay, I hope this video helps you guys. It was just a brief rundown of chemical equations. If you need any help, remember that I have second period stars, so you can hit me up during that time. Also, I'm doing help sessions on Wednesdays during homeroom, so don't hesitate to hit me up during that time. I hope you guys are grasping chemical equations because we are moving on to properties of water.